In this segment, we'll extend the multidimensional array discussion to pointers to arrays. Now, these are pointers whose target is an entire array, not just the first element of an array or a block. They're essential to understanding how multidimensional arrays are passed as parameters. Now, we saw in earlier modules that the name of an array without indexes represents the address of the first element of the array. For instance, we could declare an array of integers, like we do right up here, and then arrange an integer pointer to point to the first element with this code. The result looks like this diagram here, where I have circled P's target to emphasize that it points to just the first element of array. So, what does the name of a two-dimensional array, like image, refer to? What does it represent? Well, the first element of image, as we discussed earlier, is an array, albeit a smaller one than image itself. So the name image alone refers to the first subarray or row of image. Let's take a look here at line 35, where we declare pointer to array, and then on line 41, where we assign image into it. Now the result of this is shown in the diagram down here, where we'll have pointer to array pointing to the entire first row of image. That is its target. Pointer to array has the target of the entire first row of the image, not just the first int. Now, what's the difference between pointing to the first row versus the first int as far as the address in pointer to array goes? If the first row starts at, say, address 1000, doesn't the first int start there too? If the pointer contains 1000 in either case, why draw the distinction? That's a question, so think about it for a little bit. Coming back from a pause. Well, it makes no difference to the address in pointer to array. That's going to be 1000, say, either way. But it strongly affects the type of pointer to array. Now recall from earlier modules that two pointers may contain the same address, and yet depending on their type, which determines the type of their target, they may point to different things at that address. In other words, one may point to the first field of a struct, for instance, while another points to the entire struct. The rule to remember, repeating from earlier modules, is the address in a pointer determines where it points. The type of the pointer determines how much it points to. So, what type of pointer does this complex-looking line 34 declaration or 35 declaration up here declare? It makes pointer to array a pointer to an array. And not just a pointer to any array, a pointer specifically to array of calls, 5, ints. If you dereference ptr to array, you don't get just one int. You get an entire array of calls ints. In this case, the entire first row of image. Star pointer to array is a calls element integer array, usable like any other array. For instance, this line here, 42, dereferences pointer to array to get the first row of image, and then sets the second column of that first row to 42. So here's question 2. What are the parentheses for on line 42? Are they needed? Coming back from a pause, did you follow up on the advice earlier to review the first 2 rows of the precedence table? If so, you know that star has lower precedence than bracket. But we want the star done first, and the bracket applied to its result, so the parentheses are needed. And note something interesting. The syntax of the pointer to array declaration matches the pattern of the line 42 expression. We needed parentheses when dereferencing pointer to array, and we put parentheses in the same place in its declaration. It's not a coincidence. It's a consistent rule in C declarations, one we'll be talking quite a bit about. The syntax, including parentheses, of a variable declaration matches the syntax of expressions using the variable. Now, this has been true for the simpler types we've encountered before. For instance, how do you use a double pointer, say dp? Well, you dereference it twice, star star dp. And its declaration, int star star dp, reflects that pattern. The declaration of pointer to array follows the same rule. It's just the first time we've included parentheses in a declaration. There'll be other such examples, and we'll return to this rule as we do more sophisticated declarations. Now let's play around a little more with pointer to array. For instance, what effect does line 43 have? Where would pointer to array point after such an increment? Now reason this out based on the general rules for pointer arithmetic, size of target, and so forth. Coming back from a pause, all pointer arithmetic is in terms of the pointer's target size. So pointer to array plus plus jumps by an entire array's size. As the diagram here shows, it moves pointer to array to point to the second row of image. Now, one can also index pointer to array like any other pointer, though the index offset is in terms, again, of pointer to array's target. So something like pointer to array bracket 2 offsets pointer to array by 2 rows, offsets from it by 2 rows, and then dereferences that, arriving at the 4th row, counting the increment that was already done, of image. And that result is an array, of course, and thus we can index it in turn, pointer to array bracket 2 bracket 3, and that'll get us the second to last integer of the last row of image. Note that this makes 3 subtly different types now that we can double index. A simple 2D array, like image, is one of them, obviously. And then a double pointer, like argv from prior discussions, is another. And now we have a pointer to an array, like pointer to array. And we'll discover a fourth in a later segment. So let's try another question here. Would declaring pointer to array as pointer to array calls +1, like that, have made any difference? And what difference would it have made if so? Returning from a pause. Well, it would make the target of pointer to array larger, thus changing the behavior of pointer arithmetic and indexing. Incrementing pointer to array would jump it by the size of a cols +1 element array, for instance. And it would no longer be compatible with image, whose elements are not cols +1 element arrays. So line 41, for instance, would get a compile error. The particular type and size of the target array matters when declaring a pointer to array, since it determines the target size and the expected type of the elements in the target array. Now let's take a look now at the line 46 call of 0-2D array. We're passing image to it, but as we know now, that's really passing the address of the first row of image. The formal parameter, up on line 6, reflects this. It is a pointer to an array. The function's code double indexes that pointer to set all elements of the array to 0, just as if the pointer were a 2D array. But the comment shows equivalent pointer arithmetic code we might have used on line 10, and in fact what we are doing is indexing a array pointer or pointer to array to reach back into image. And the comment on line 6 shows an alternate declaration. As you know from prior modules, the notation x empty brackets in a parameter declaration, and only there, is a synonym for star x. It declares a pointer. So we can replace the complex declaration on line 6 here where we said star array with just array empty bracket calls, and we don't even need the parentheses anymore since bracket to empty bracket has equal precedence to the bracket calls now. Question 5. Could we write array empty bracket empty bracket? Apparently not, since the comment says not, but what would be the problem with that? Coming back from a pause, well, we'd be declaring a pointer to a pointer. We're not declaring a pointer to a pointer, we're declaring a pointer to an array. The calls bracket specifies the size of the target array. We need it in order for the pointer to an array to behave correctly. Now, just for variety, look at how copy 2D array works. Instead of indexing TRG and source, we increment them through the 2D arrays to which they point, one row at a time. This copies one two-dimensional array to another. And the only index used is to offset by call within each row. And the final example function down here is make dull movie. And this is passed a three-dimensional array to parameter targ and a two-dimensional array to source, and it copies the 2D array into all layers of the 3D array. The call down here on line 47 shows how we might call it. Now, question 6. What type is parameter TRG on line 22? Extend the ideas we've discussed so far. And in particular, by how many bytes does it advance when it's incremented on line 27? Coming back from a pause, it's a pointer to a rows by calls two-dimensional array, or array of arrays. So line 26 advances TRG by the size of one rows by calls int array. That's 20 integers, or 80 bytes. If you'd like a diagram, let's take a look at what we'll be doing down here. TRG, if passed movie, would point to the entire first element of movie. And when we increment it by 1, we advance to the entire second element of movie. Thus. And in the next segment, we'll look at how to dynamically allocate multidimensional arrays.